Welcome back to Coding Drift. In the previous video, we have seen how to reverse the linked list. In this video, we will see linked list with the tail. So consider this append method. If you see the complexity, right, the complexity is big O of n. It has a linear time complexity. If you compare it with arrays, arrays have a constant time complexity. You just need to push to the array, but here you need to traverse the entire list and then append an item. So can we optimize it? Let us say how we have a head pointer, we have a tail pointer as well. So if we have a tail pointer that is pointing to the end of the list, then we can just append the item with just one operation, which has a constant time complexity. So let us go to the slides and understand it better. So this is how a linked list with tail will look like. In addition to the regular linked list, it will have a tail pointer which is pointing to the last item in the list. Now let us compare linked list with head with the linked list with head and tail. So this is how a linked list which is empty looks like. Where there is only head, it will point to null. Where there is both head and tail, both head and tail will point to null. And when a single node will look like this, in case of linked list with the tail, it will have both head and tail pointing to the only node which exists. And coming to prepend operation, it is both similar here. We will first point the newly created node to the head, and then we will point the head to the newly created node. There will not be any update to the tail, so both the operations are same. And coming to append, this is where there is change. Here, while appending, we will traverse the entire list and find where the previous dot next is null. Then there we will insert the new node. But in case of tail, we will just do tail dot next is equal to the newly created node, and we will point tail to the newly created node. So this is where the advantage of linked list with the tail comes. You just insert with one operation, no need to traverse the entire linked list. And coming to delete operations, when you want to delete the only node that exists, then you will just point the head to null. And in case of linked list with tail, you will point both head and tail to null. And if there are more than one node in the list, then if we are deleting from the head, what we do is we just point the head to the next node here. Same in the case of linked list with head and tail. So when it comes to deleting from the tail, you have to traverse the list in both the cases. And only thing you shouldn't forget is to point the tail to the previous node before deleting the tail node. So those were the differences. In the next video, we will implement the linked list with tail. Hope you're liking this series. If you are, please consider subscribing to the channel. See you in the next one.